Hello everyone, I'm Yatharth Swaroop from Encryption Consulting, and today we'll be going over the basics of homomorphic encryption. First, we'll talk about the types and need for homomorphic encryption. Then we'll dive into its applications and finally state its advantages and disadvantages. Let's begin with understanding what is homomorphic encryption. It is a method that allows any data to remain encrypted while it's being processed and manipulated. In other words, we can say it enables you or a third party, such as cloud service provider, to apply functions on encrypted data without the need of revealing the exact values of data. Like other asymmetric encryptions, HE is encrypted using a public key and can only be decrypted by the respective private key. It's of three types. First is fully homomorphic encryption. It allows any number of operations of multiplications and additions to be completed on the encrypted data. It is considered perfectly suitable for any kind of application that is waging with encrypted data. It is a bit less efficient as compared to other techniques because of additional computational overhead. Then we have partial homomorphic encryption. It allows either one of the operations from addition or multiplication to be achieved on the encrypted data, but does not allow both operations at the same time. This idea is useful for claims which require some precise computation to be performed. The third one is somewhat homomorphic encryption. It allows more than one action to be performed on encrypted data, but in a limited way. This scheme is suitable for applications in which real-time analysis of data is done. In it, there are limited operations and hence it is considered faster than other schemes. Now let's talk about the need for homomorphic encryption. Data is being created at an ever-increasing rate, and it is sent or stored in multiple environments belonging to other parties such as CSPs. From startups to big organizations, everyone uses CSPs to store or process data. However, it provides only limited control over the data to customers. Users can encrypt and store data on CSPs, but conducting computation on the data would be limited. Thus, standard encryption is only limited to data storage alone and does not provide any meaningful analysis that can be used, whereas homomorphic encryption focuses on privacy-enabled computation. Now let's move on to understanding various real-world applications of homomorphic encryption. First is private search. Search engines provide customized ads to their users while serving them searches. HE helps search engines to crawl encrypted data and serve it to the users while remaining unaware of the data requested. Next is encrypted databases. Databases are often the most crucial infrastructure to protect. If we deploy standard encryption, the encrypted database will not allow any operations on the records. We can use other forms of encryption, such as deterministic, order preserving, order revealing, but all these would lead to leakages such as memory access patterns and search patterns. However, with homomorphic encryption, it is possible to encrypt the database to obtain confidentiality, while we can also perform operations and computation on the data. Other application is computation on cloud. Using HE, we can secure the data that we store in the cloud while also retaining the ability to calculate and search ciphered information that we can later decrypt without compromising the integrity of the data as a whole. Next, we have is elections. In elections, HE is used to obtain the tally given the encrypted votes without decrypting the individual votes. Next application is watermarking and fingerprinting. Digital watermarking and fingerprinting schemes embed additional information into digital data. The homomorphic property is used to add a mark to previously encrypted data. It is also used in genomics. HE permits encrypted genome data to be computed on without decryption, thereby allowing us to perform all types of genome analysis. Moving on to national security. With the development of smart grids, homomorphic encryption can be used to protect customers' data aggregated from home, building, and neighboring area network. Next is healthcare. HE can be used to balance the risk and utility of health-related sharing of data. Last we have is finance. HE allows financial institutions to share data internally while ensuring financial and privacy compliance. Now let's weigh the advantages and disadvantages of homomorphic encryption. First benefit of HE is that it enables collaboration with third parties. HE allows organizations to share sensitive business data with third parties without revealing the data or the results of the computation to them. This can accelerate collaboration and innovation without the risk of sensitive information getting compromised. The other advantage of HE is that it allows secure and efficient cloud use. HE enables businesses to leverage cloud computing and storage services securely. Organizations don't have to rely on cloud services regarding the security of their private data while retaining the ability to perform computations on it. Last advantage we have is that HE ensures regulatory compliance. HE can allow businesses operating in heavily regulated industries such as healthcare and finance to get outsourcing services for research and analytical purposes without the risk of non-compliance. Now let's move on to understanding the disadvantages associated with homomorphic encryption. First is that it is slow and non-performant. HE computations are incredibly slow, and only a finite number of operations can be performed on the encrypted data. Next is that it is not feasible for multiple users. If we have a database which needs multiple users to access it, we will have to create a separate database for every user, which is encrypted using the user's public key. This would become impractical if the number of users increases or the size of database increases. The last and most significant disadvantage of HE is that it requires dedicated and specialized client server applications in order to make it work, thereby increasing total cost of ownership and distracting the organization for more important and strategic initiatives. That will be all from my side. Thank you for watching, and to learn more about encryption and data protection related terminologies, please visit our website.